Hello everybody. So it's been a while since I did any videos and updates, things like that, so I figured it's probably high time while I got a few minutes to do that. So I'll probably just try to keep this one short and sweet. I've been mucking around with this camera for several hours, and the reason it's been several hours is because of this guy right here. Yep, we've got one of these guys. No, I'm not going to pull him out of a box and demonstrate him. He's in his room and he's asleep. He's about 4 months old now, and we've had a rough maybe last 6 months. He was born 2 months early. Mom had a really rough pregnancy. We had bleeding. We had all kinds of problems. Starting around week 32, week 31. You know, we made it all the way to week 34 before he was born, and they were just like, we have to take him out. Because it was going to threaten her life and his. It's like, we have to do it. She started to hemorrhage, and of course, here he comes. So we got him, and everybody's alive and well. He is, you know, like I said, now he's 4 months old, and he's a fairly happy baby. You know, we had a lot of issues with him. Spent a month in the hospital. Mom spent about 2 weeks, 2-3 weeks in there. You know, it's been rough. So now that that's pretty much over, the rough part is that well, you have him, and well, he needs feeding and diaper change and attention and all that kind of stuff. So maybe before long I'll have him sitting up here, and there he is moving. Actually, he's just stretching or doing whatever it is. So if he starts wailing, of course I'll have to get up and, you know, go and tend to him, which I think he's probably going to do. He's starting to wiggle. That's usually cue for feed me. But I've been playing around with this camera, and the backstory behind these cameras, we got a bunch of these cameras, and these are Honeywell HD31s, and we've had a whole bunch of these things fail, and we've got some inside, we've got some outside, and we've got some in a data center. So the data center ones are kept the coolest because that's the one place that the temperature is fairly constant. The office area of the building that fluctuates a lot more, and of course outside fluctuates the most. You know, and is subject to humidity and things like that. So they've been under warranty, and this is the first one I've got my hands on, because now they're not on warranty anymore. So now you have to pretty much buy them and replace them. But I'm thinking that these really need to be swapped out for a completely different camera as they fail, for the simple reason that the damn things don't seem to last very long. I mean, they last like maybe 9-10 months, and then they fail, because they're all new, and you know, over the last year, they're over a year now. We started having them fail, with the exterior ones failing the most, and the interior ones failing usually shortly thereafter, and then the ones in the data center, I think only one of those has failed, but the rest seem to be okay. It just seems that they're definitely failing at a different rate. So that tells me immediately, before I even cracked it open, that the things must be there must be some kind of thermal problem, because if it was humidity, you could probably just see condensation inside the camera, but you never could see anything in them. And since they were just under warranty, you pretty much just pull it down out of the mount, you know, hand the camera off, you get another one, you put it up into the mount, and move on. But so this is the first one I pulled apart. I did fix it. The issue with this is definitely thermal in nature, and if I don't know if it can be seen, we got a BGA package here, and we've got a label on it. You know, it says NTSC, which is never the same color. I know the NTSC guys are going to go and sort of mock me a little bit for that, but yes, I always refer to it as never the same color, because it never was. But anyway, that's gotten really hot. And then of course we've got the power cabling that comes in here. I mean, the thing is so brittle that when I unscrewed the gland and pushed the cable in a little bit, and then unscrewed the two halves of the sphere, and the thing was broken. So I said, oh well, that's the problem. And you look at it, and the cable is just so brittle and stiff and hard. It's just gotten so hot, and the connector has even gotten discolored. You know, I mean, So, I mean, the thing has gotten so hot. It's like, okay, well, it must be, you know, thermal expansion and contraction and things like that. And sure enough. But here's where I think where part of our problem lies. Underneath this side of the board, you got your CCD imager, which is mounted to this board right here. You may be able to see the pins there for it, which are interestingly enough are not seen to be soldered all the way through, but it seems to be good enough. But right underneath this connector right here, and underneath this connector right here, you got buck converters, and the camera takes, you know, 12, 13 volts. And then we got buck converters in here that, you know, are going to drop that down to like 3 and 5 volts. So, you know, as a rule, those things are fairly efficient and you shouldn't have too much problem, but they do make heat. So now we got a camera that, this particular camera was inside of the building, near an exit door. So, you know, inside of the building, it's definitely in the 70s in the summertime, in the 70s Fahrenheit. On the weekends, I think that we let it go up into the high 70s, maybe 80 degrees, you know, conserve power. So on the weekends, it's going to get warmer. But this thing has suffered from some fairly serious thermal issues. And I just cannot understand why, okay, under these connectors, they put these buck boost converters. I mean, they're literally right along the edge of the board. I mean, you may be able to see one of them there, and there's the inductor poking on that side. There's another, you just can't see the inductor. There's another inductor under there. It's gotten so hot that it's just cooked. I mean, the wires are just coming off. They're so brittle and stiff on these connectors, like this one that goes to the iris. This one, I mean, literally they just break off. Because it's gotten so hot and they're so brittle. So we got our BGA here that's making a lot of heat, and then we got these buck boost converters on this other side of the board, and over on this side of the board we have like literally nothing going on here except for some driver, I don't know, looks like it's a 8-pin flat pack. And it's just driving the iris motor, and that's literally all there is on this other side of the board. So we've got all of the hottest components on one side of the board, and what's so interesting about that is that the thing sits in the housing like that. So the hot parts are on the bottom of the thing when it's sitting when you're having it you know, upright. I just don't get that. So why would they have the heat going into the CCD? I just don't understand. It doesn't make sense to me. Maybe it's an assembly fail, since I don't know. There's clearly some design fail going on here, because, you know, with all that heat and whatnot of these connectors. So I don't know. I mean, I fixed the problem with it, which is, I mean, it just cooked itself. But, you know, repairing one of the buck converters that's in here is just going to cause it. I mean, all I did was replace a bad regulator that had cooked itself. So and the inductor too. That inductor is also replaced. It's going to happen again. Of course, the wiring. You know, I didn't use the cabling. I just sort of powered it up, with another with some alligator clips on, soldered some leads, some 0 ohm resistors in there so that I could clamp to, because I have to repair this. So the connectors are all discolored and they're all brittle. It's just a design fail. So I don't know. My thought is that I'm thinking like a 7809 or something, some kind of linear regulator stuck to this aluminum plate, because we got plenty of it here to heat sink off of, and then it screws into this metal, aluminium sphere that is inside of another piece, the mounting bracket. I should think there's plenty of opportunity to sink off some heat, but the idea being to not have the buck converters working so hard on these, because this is thing 12-13 volts. you know, we're getting really hot over here underneath these connectors. So what I'll probably do is delete the connectors, just take them off, take the cabling straight to the board, because they're just baked. It's so brittle, the wires are so brittle, I don't know that they're really salvageable anyway, but it is working now. And then, you know, just take the cable, you know, straight to the board, and then, you know, take the power coming in and, you know, whack a 7809 or 7810 or something like that, some kind of, you know, 910 volt, maybe a 7808, all of which I know I've got laying around in here, probably in large quantities to boot, mounted in there, and you know, just to keep this from getting so hot. So if we're going to sink a bunch of heat, and I know these are that they're buck converters and they should be, you know, fairly efficient, and you know, I mean, for the most part they are, but they still make heat. And one of them is driving another switching transistor or MOSFET or something like that. It was a MOSFET. So, you know, we've you know, we're making too much heat for these connectors basically, and I just don't understand. I mean, this is a, you know, supposed to be a you know, well-respected company. It's just the second page of the specifications of the camera, and that's what the camera looks like in its housing. I mean, come on, guys. You know, power consumption 5 watts. So yeah, obviously we're consuming a lot of power, a lot of the 5 watts here in heat. I don't get it. Anyway, so that's just you know, what I'm toiling with at the moment, other than the work-related stuff that I've got to toil with. So now we've got 2016, you know, started. I can, you know, and we've got baby situated and mom situated, and everybody is doing well. I can probably, you know, get back to, you know, doing some stuff over here. You know, and I've actually got a ton of stuff piled up around here. I've got broken Surface Pro tablets. I've actually got a pile of these around. These are when they break these, and the thing is that these coming from a public safety, so they break these things, and you know, it's not an intentional thing. They just you know, it's the conditions that a lot of times they're encountering when especially like EMS, when they're dealing with a patient, and you know, they just get dropped or sat on or something, or banged, and that's what happens. You end up with these nice impact areas like that. I've got a pile of these things. I mean, I haven't tried to replace a screen in one of these, and these are not Windows RT. These are actually Surface Pro 2s. So this is you know, the real deal. You know, and these are you know, $600-800 US, so fairly expensive. When they break them, we just switch them out and move on. It's at the moment it's just easier, and they don't break them that often. So so I got that. I mean, we were you know, toiling around on DSL reports, once again talking about the UVerse system. So I got my gateway to rip apart here. You know, for those who don't know anything about these things, this is their more or less proprietary VDSL 2 modem that you know, you have to have theirs. 802.1x done in the modem. Don't ask me why. It's dumb. Well, that's AT&T for you. So they feel they need extra security. It's crazy. So I'll probably tear that apart again, because people ask me to explain its workings. I've got a couple of old point of sale systems. These Wingcore Nixdorf. These guys make point of sale computers for ATMs, and I got a bunch of these things. This thing is absolutely frigging ancient. You know, we got a label on the back. It starts talking about the operating systems, DOS or Windows 98. preloaded onto it. So yeah, really old. So I'm not sure that that'll be very interesting, which is kind of why it sits over here. Very interesting modular design though. Like here's a power supply for it, and you know, we've got our funny connector, our funny D sub with the two large pins for probably the 5-volt bus or the 12-volt bus, or the 5 and the 12. Who knows? I haven't measured it. So I've got a bunch of stuff to do. I just haven't had a whole lot of time because of this guy. So you know, he's actually being good for me now. He's not demanding attention. So I don't know what else, guys. I mean, that's basically it. It's just trying to get my bearings and fiddle far around with this some more, and you know, go from there. We'll see what else I can get going in 2016. Maybe I'll fool around with the surfaces. You know, I'm not sure how interesting this is. I mean, there's videos of people tearing these things apart, and you know, I'm not. It's just a tablet computer. It's not very interesting to me. I guess to me, it's not very interesting. You know, it's that one came from EMS, hence the label. Oops, did I just? I didn't even see. It didn't even see how I tapped that, but the screen's already broken, so I guess it doesn't matter. But hit the camera. So I just have to, you know, sort of re-engineer this, you know, because Honeywell had a sort of a design fail. So I'll redesign their power supply and their camera for them. Anyway, guys, that's pretty much it in my life. I see everybody else is still around. Everybody else is doing good, so that's great. And so am I. So anyway, guys, till next time, you know, have a good 2016 and all that kind of good stuff.